Okay. Sorry for the delay there. Let's get this going. All right. Hey everyone. So we'll be doing a bit of a faster stream today, I think. We're down to the last two modules here. We'll be building the LFO and the envelope. And I think what I'm going to do is I think I'm going to approach this as kind of a simultaneous build, the same way I did with the VCOs. So I'm just going to get set up here. I've got other project work that I need to get to today, so I want to, work through this and I want to do these modules justice, but I also want to see how fast we can go without being sloppy. So, as I get this sorted here, had a very interesting trip over the weekend. If you are anywhere near eastern Pennsylvania, and like by anywhere near, I mean if you are within, miles, and it's a reasonable drive across a day or something, I would highly recommend the place called EMIAP, which is the Electronic Music and Preservation Project, or the Museum of Music Technology, I think is the other name they go by, MTM. And yeah, we took a trip out there yesterday. They kind of did a favor for us. They usually only do weekday tours, but they were willing to do a Sunday, and I took a group out. Wasn't as big a group as I wanted, but it was a good-sized group anyway, and we took the tour, which is like a 3-hour tour. And oh my, if you are a fan of synthesizers, especially vintage ones, or even, if you're like a big Frank Zappa fan or a big Keith Emerson fan, any of those territories are very well covered there. They have a couple synths in the collection there that I had only ever seen the name of and had never actually seen one, let alone in person. And a bunch of the stuff is operational, and they fire it up and will let you play it and such. So I mean, they have like the original Fairlight and a later edition as well. That kind of stuff isn't quite so crazy, but they have like Oberheim SEM stuff that I didn't even know existed. They have a black SEM, it's like, because it was just something that Tom attempted as a production test and didn't like it, and so they never got produced. But things like that. Like they have Frank Zappa's guitar rig. They have a gigantic amp collection. It's like warehouse space, and it goes up racks to the ceiling. I mean, it's crazy stuff. And they have Keith Emerson's touring Moog, like the giant wall of Moog that he used to take on tour, the actual one. There have been recreations. I think there was one at NAMM this year. Sorry, NAMM. Yeah, really amazing collection. Highly recommend it. Super sweet people, very nice. They had some volunteers in training there as well, who were learning how to give tours and stuff. It was a very good time. All in all, spent about 3.5, 4 hours, something like that, on site, and really, really great people. Highly recommended. Let's see here. So we've got our LFO on the right and our envelope on the left here. And I'm going to run through the material like I always do and just kind of give the background of this. And then we will get to work here. I want to see what we can do in this. I want to see if I can get through this by noon. I think that should be an easy thing, but we shall see. I of course am on Eastern time, so it's about 10:16 a.m. here. So, all right. So, as always, I'll just kind of read through what Ben has written in the book here. Oh, and in case you happen to just be tuning in for the first time, I've done a series of these streams now. This is actually the last of the series, building out the modular itself. And I'm realizing I'm rushing a little bit here. Let me show you our previous progress in case you're just joining us for the first time. Okay, so on prior streams, and they're all archived on YouTube if you're interested in watching them. Let me get this, make some room here so I can get this on screen. So, is that visible? Yeah, that's good enough. Okay, so we have the two VCOs, a malt, the VCA, VCF. This is the power inlet. We have a microcontroller module. This one I have not yet gotten a chance to figure out why this USB-C connection isn't working properly. I basically have to connect directly to the, I forget, I think it's a Raspberry Pi on there. I have to connect to it directly in order for it to be recognized on the system. There's something up with this little, essentially, it's almost like a dongle, but without any circuitry in there. It's just an extension that converts to USB-C. For some reason that little piece isn't working for me, so I need to sort that out. Then we have the mixer and the attenuverter and another malt. So we will be filling in with the last two modules and then have a blank at the end to round everything out. The gaff tape here is because the way the kit works, you actually have to tap the holes yourself in the aluminum casing, and I had a couple failed attempts there. So the gaff tape is holding those screws in place because otherwise they would just kind of work their way out. And I am going to have to source 4 more M3 screws. I mean, I have a ton in the back room, but I'm going to have to pull some out because it seems in the kit I only have 2 more. And I also seem to be down, and I can't remember, I may have dropped one when I was working on this on one of the earlier streams, but the nuts for the pots, I seem to be down a nut, so I'm gonna have to sort that out too. But otherwise everything's very complete, and there was like 1 extra of everything in terms of resistors and stuff in the kit. So this is where we are starting. And last week, and I'm sure we'll do it again at the end of this session here, but last week I did kind of plug all this in, test it. You can kind of hear what it all sounds like, what the filter sounds like. It's a very interesting filter. It's very, it's got a very interesting character for its resonance and such. I think because it's such a simple circuit, it's pretty unique. I feel like I'll be able to get some pretty gnarly sounds out of this thing. So, oh, and just for background on this too, for any of you who are familiar with my stuff, and we'll just kind of transition to this for context real quick. Excuse the mess as always. I pre-ordered it when it was announced because it's just a really cool project, and I just really wanted to support the project. But that, it arrived like June of 2025, I think, maybe even earlier than that. June of 2024, possibly. I don't even know. Point is, it took me quite a long time to get around to building it, just because, I don't have a direct need for this stuff, but I'm very glad I supported the project. It's a very well done little project for a first modular, for a starter. If you are not familiar with modular and you also want to kind of learn about the circuits a bit and have schematics and kind of understand everything that you've built, I mean, it will require a little bit of research outside of the material in the book with the kit, but like Ben does a really nice job of breaking everything down and just kind of explaining the circuits. So I did also clear with him to kind of read through the material in the book on the streams. I don't ever go over the schematics. I kind of feel like if you want to get that deep with it, you really should just buy the kit. The kits are available at Thonk. I haven't checked current stock. I imagine they are in stock, but I don't know for sure. And then also on the Clacktronics site, if there are other retailers available, they will have links there. I'm not sure of the status of that at the moment, but I will include links to all that stuff in the final version. I haven't had time yet, but once this stream concludes, sometime this week, I'm going to go in and there's some cleanup I have to do on some of the previous streams. Like one of them got saved with the wrong date and the title and stuff, but I'm basically just going to create a playlist of all the streams so that you can kind of work through if you want to see what the builds look like. That way all the videos are there and you can get a sense for what it's like to put this thing together. I was kind of developing the setup for these DIY streams, as I was working through this stuff. So, that's not, it doesn't start out with the most ideal setup, but you do have a decent view of everything that's happening. It's similar here. I mean, it's not perfect. I've got some glare with this ring light and stuff up here. I should probably find a way to kind of diffuse that a bit over the sections, like right there and there, basically, so that you could see the PCB a little bit more clearly. But, it is what it is. So we're working with this for now. So anyway, we've got the low frequency oscillator here. We'll start with the description of that. Just kind of run through it real quick. And also the circuit description. Let's see. This is all just one page here, right? Yeah. And yeah. Okay. So low frequency, and for any of you who are familiar with modular synthesis, most of this content here is going to be stuff you're already aware of, but there may be some details when we get into the circuit description that would be new information for you. It depends on how well versed you are in this stuff. But so low frequency oscillator, now we have all our complete voice chain, the VCO to VCF to VCA. You will probably start to want to create something other than constant drone music. The LFO is a way to add interest to the sound, and it is essentially the core component of a tremolo, wobbly amplitude, or a vibrato, wobbly pitch, sound. We want our oscillations to be relatively slow, much slower than 1 Hertz, and up to a few tens of hertz to achieve these effects. Additionally, we likely want a range of shapes to produce different effects. You might wonder why it is not voltage controlled. You can do things with voltage controlled low frequency oscillators, and you could modify a VCO to operate at such low frequencies, but in practice it does not come up that much in patches. This is because this module generates control voltages, and you may find that you usually don't want the frequency to track with the pitch. The LFO we are building creates 2 types of waves simultaneously, providing many options with a very simple circuit design. The 2 outputs are a pulse and a ramp. The ramp is much like our VCO, except we can control it to ramp up, down, or both. The pulse is a square wave, except the high and low periods are variable. LFO module, this is our first proper CV source for our modular. The frequency knob is as you imagine. It can be turned up to almost audio frequencies at full clockwise and very slow at anti-clockwise. You will find a bit of an odd dead space at the lowest end. I left it in because it is actually moving incredibly slowly, which can be useful. the shape knob lets you alter the ramp steepness of slope and the pulse length of pulse. Halfway, you should get a triangle at the slope output and a square wave at the pulse. Either way, you will get a sawish ramp rising or falling and a pulse that is briefly high or briefly low. The LED turns off and on with the pulse output for indication of frequency. Plug this module into the mixer or attenuator before plugging into other sources to get variable amplitudes. So the specification is it's 10 milliamp on the 12 volt positive 12 volt rail, 10 milliamp on the negative 12 volt rail, and it's saying the construction is an easy 30-minute build. So then the circuit description says this is a much easier circuit to understand than the VCO because we do not have volt per octave control. It is simply resistance-based frequency control. We start with the same principal component as the VCO, an integrator as shown above, but with more capacitance. This is an inverting op-amp, so the voltage difference at the input is opposed at the output. The three capacitors can be treated as one with 3 times the individual values. So because we have 3 100 nanofarad capacitors, we are left with a 300 nanofarad equivalent capacitor. When we put a positive voltage at the input, the output pushes in the opposite direction, and because the 300 picofarad capacitor is there, sorry, just trying to, oh, right, okay, that's, yeah. Initially, all seems fine. The output and input are as if shorted when the capacitors are discharged, but then, as the capacitor starts to charge, the difference between the input and output grows, which in turn causes the output of the op-amp to fall as it tries to bring the two inputs to the same voltage at ground. Without further circuitry, the output will continue to fall until the op-amp saturates a couple of volts from the negative rail. This is not much of an oscillator. We need a reset switch, and this is created by a comparator with hysteresis like the VCO. The very low positive feedback on the comparator allows the oscillator to swing between plus minus 5 volts. So when the comparator voltage is triggered at low, it will output approximately negative 10 volts, which is fed into the frequency potentiometer. This attenuates the voltage as needed. Lower voltage results in slower oscillation. Then the second potentiometer directs that plus minus 5 volt signal through 2 diodes, which allows us to direct the current to be faster on either the rise or the fall. And then there's the full schematic. It is not perfect, as in this configuration the frequency will slightly change as the shape potentiometer is adjusted. I could have limited this with some resistors at each end of the potentiometer, but I decided it's best to keep the full range and tolerate some oddity, as the LFO does not have to create musical pitches. As shown in the main schematic, a non-inverting amplifier, U1B, takes the comparator output and drives the ramp output. An inverting op-amp section, U1D, takes the comparator output and halves its voltage, producing an approximate plus minus 5 volt signal. The LED indicator is driven from the comparator. It is reversed because at this stage the comparator output is opposing the output of the integrator. I had to put a reverse voltage protection diode on it, as LEDs cannot tolerate significant reverse voltage. For the construction, it says, again, pretty straightforward construction. Just follow the basic step-by-step process of adding small components first and ending the large back components. Take care of part numbers and orientations. And then we'll skip troubleshooting because hopefully we won't need it. And patchy notes, you will find the output of the LFO plus minus 5 volt is a bit hot for most of the CV inputs. You'll need to put it into the mixer or the attenuator to bring the signal down to a place you might want it. Okay, then we have the bill of materials, which I've marked off for all of the parts that I set aside here. And then we'll go through the envelope description because we're going to be building both side by side here. So the envelope is a module designated to work with gates. Gates typically come out of modules such as sequencers, keyboards, and other musical CV control devices. Gates basically tell other modules to be on or be off, whereas a trigger is more like start now. The envelope in this system is a very simple attack release generator. If you imagine passing a gate into a VCA, you would have the sound come on when it is high and turn off when it is low. The envelope is concerned with the attack, adding a slow ramping up when the gate first turns on, and the release, where the output ramps down slowly when the gate drops. This creates the effect of decay found in many musical instruments, such as the decay of a plucked string or the attack of a violin note. Triggers can be used with envelopes, but they have to be long enough to charge the attack stage, so setting the attack to the lowest value is a must. The decay stage happens after the trigger signal has dropped, so it is not affected by trigger inputs, but it only occurs if the attack has been sufficient. Envelope module. It says the envelope is quite an easy module to understand. You need a gate or trigger on the gate input. Then you attach the out to the module you wish to control. Attack and release are as described in the introduction. Attack should be much shorter range than release. If you are unsure it is working, turn attack and release fully counterclockwise. This will mean the out is pretty much the same as gate. Then bring up release. The LED indicator should help to show the envelope is open or not. Specs are 10 milliamp on both the plus and minus 12 volt rail, and it's saying it's a medium difficulty 30-minute construction. And then for the circuit description, in our envelope circuit we aim to make a positive only control voltage, since our VCF and VCA are two quadrant devices, which means they only open with positive voltages. We take in a gate signal. The gate represents a window of time during which a sound is playing. When it is high, the sound is on. When it is low, the sound is off. This is only how to think of it when using a VCA. Of course, it can Of course, it can also be used for changing pitch, cutoff, etc. When the gate first rises, we will follow this rise at our desired speed, known as attack. When the gate turns off, we fall at a defined speed known as decay. We start by taking in the gate signal. I use an op-amp as a comparator to help condition the signal. This also helps if your gate is not stable, such as when it is a waveform or if you touch the jack tip with your finger. The 1M feedback resistor is for hysteresis, which stops the input from bouncing around when near the threshold. The voltage divider on pin 2 sets the threshold at which it considers the input high, because that is when the comparator flips its output to high. Because we use a comparator, we need to get rid of the negative voltages when the op-amp swings low. This is simply done with a diode, which rectifies the input to be positive only. Because the diode blocks current in the reverse direction and the input impedance of the op-amp is very high, we need to use a 100K resistor to pull down the input on pin 5. Otherwise, it will charge up and be stuck permanently high. And then again, full schematic here. Then with our positive gate, we charge a large capacitor through resistors. The diodes ensure that the current only passes through attack when the gate goes high, charging the capacitor, and it discharges through release when the gate goes low. Potentiometers control how fast the current charges the capacitor. Two capacitors in series, as shown, actually have the capacitance, which is what I wanted. We get about 50 microfarads. This is the value of the capacitor I wanted, and it is better to use a part used elsewhere rather than introducing a new part. Construction. Another straightforward build that follows the convention of this book. Take care to get the right side of the PCB. And patching notes. The main function of this module is to plug it into the VCA, set up the VCA, and plug the out of this envelope into the CV of the VCA, turn amplitude all the way down, and send gate to the envelope. You start hearing a gain envelope. You can plug the envelope into the VCOs or VCF to get other effects. Okay. So then we have that bill of materials. Once again, I'm gonna just kind of build them side by side here. So I'm going to, I think what I actually want to do is maybe pull the page with the envelope bill of materials so that I can kind of at least have them sort of back to back, if not visible at the same time. So let's get that out of there. I'll put it back later. Okay. And so we'll have these here. And let's get started. So, as always, starting with the resistors, we'll start with the LFO here. So we have, you know what, so that I don't confuse myself too badly, I am, oh actually no, they are in orientation to their place on the, alright, you know what, I'll leave them like that. So, I've got the most of the 100K resistors here for this one, so we've got 6. It's R1, R3, R4, R6, R7, and R8. You know what? Let me grab my tweezers, because for these, I just like to bend the legs directly. Alright, so kind of starting backwards here. I usually start with the lowest values first, but so R1, it's right here. R1, R3. So with these, when they're a pretty narrow footprint on the board, like basically the size of the resistor, I have one of these to just kind of bend the legs, but I find it actually works better at this size to just use these iFixit tweezers and just kind of bend the legs directly. Alright, R3 is that R3? Yes, okay. R3 is here. R4. There's R4. Next is R6. And R7. Okay, and R8 is the final one. All right, then we've got this 2.2K resistor. I just want to test this one real quick because I grabbed it and I wasn't really sure if I was reading the label correctly. 1 second, I have to get my, oh wait, never mind. Look at that, how convenient, it's right here. I thought it was in the other room. I've been doing a bunch of repair work on the console, and this had been spending a lot of time in the other room, but I guess I brought it back. All right, so let's just double check. Yep, 2.2. Okay, good. If ever you are unsure of resistance, for me anyway, I find it faster to just test with a multimeter instead of having to reference the color barcodes on them, because I have to put them under the microscope to see them well enough, because sometimes the colors get a little obscured over the blue casing. It's just faster to use a multimeter to test it. Alright, R2 is up here. I think we have enough room to squeeze that in there. It's close though. Actually gonna have to pull that down a little bit because soldering that close to the clamp is not great. Alright. So that was R2. R5 and R12 are the 1K, which is this here. Alright, R5. Oh, there it is. R5 and R12. Those two. Then we've got an extra one here. It looks like this is 100 ohm. You know what? Let me clip that. Well, let's just pull these two out, see if I can keep the other one intact. There we go. Okay. I'll set that aside because that's got to go back in my storage. So R9. R11. Oh, there's R9. I see. So there's R9 and R11. Alright, then let's place the diodes. So as always, these diodes are, they have a polarity that has to be respected, so just make sure those are going in the right way. I believe that's the right footprint size-wise. I forget though. Let's see, did I overdo it? Or is that right? Nope, it was that leg back out. Okay. Let's try that again. Okay. Two more. Okay. So before we solder all those, let's do the placement on the envelope. So whatever I grab here, I guess will be what'll go first. Nah, just lay them out. So this is probably, what's this one? Is this the 1M? Yeah. All right. Let's place that first. That's R3. And you know what? I'm just realizing. Let me just. Okay. Just realized I didn't have any form of the chat in front of me here, so wanted to make sure I pulled that up. All right, then we are. These are. Let's get the 100K, which should be these here. Yep. So R1, R5, and R6. We're gonna take those. There's R1. R5. There's R5 and R6. Okay, and what are these? So we've got the 1K. So these should be the 10K. Is that correct? Yes. All right. So we've got R7 and R8 are 10K. Okay, and then our 1K, R2, and R4. And R4. Down there in front. Okay. And then our diodes. So again, this also has 5. Okay. So we can get this book out of the way for the moment. Set that over there. Got a little pulled in here so I'm not straining my back so much leaning over this stuff. Alright. Let's clean our iron. Oh, you know what? Let me set up the fume extractor. So again, I'm still using leaded solder here. If you're doing the same, I would not recommend it. I'm using leaded solder that also has like a flux core, so I would not recommend doing that without ventilation. This is not the most ideal setup. It needs to be closer to the work, but it's what I have to work with for now for these streams. This is going to add a bit of noise, so apologies for that. Let me try to move the scope over a little bit. Oh, this thing is so heavy. Okay, that can get us a tiny bit closer. That should help a little. Again, this really should be like right on top of the work to fully pull the fumes, but it'll help. It's better than nothing. And I could turn the speed up a bit, which would increase the suction, but then it's going to be super loud on the stream, so I'll just do my best not to be inhaling the whole time. Okay. Now we should be good to start here. So I'm just going to start kind of from the bottom up. And again, with easily accessible parts like this, where the pads are still very accessible once the part's in place, tend to go top down. Then I clean up the backside and just like kind of reflow anything that needs it. I just find it easier. Less work, don't have to bend out the resistor legs and things. If anyone knows of a reason not to do it this way, then, certainly let me know, but I've never had any problems, so. And I've built a lot of modules and things at this point, so I think it's safe to say it's a reasonable practice. Okay, that's one. Okay. And that looks like we got all those. That's 2. All right. So, then, next step. Flip them over. Clean up all these leads here. And I'm just going to reflow any that need it. Add a little bit of solder on the underside. Again, this is probably a more time-consuming approach than is necessary. I know I say I find it easier this way. I just find it, I guess, more straightforward is maybe the way to say it. It is still probably more time-consuming to do it the way I do it. So I don't know that I would recommend adopting this approach, but this is just what I like to do. And again, I rarely have failures in builds, so while it is a bit of extra time, it does seem to create very secure connections, so there's that as well. And these obviously are just flat clippers, so you can get as close to the PCB as possible. You do want to be careful not to scratch anything, because you can kind of scratch that UV coating if you're not careful. I don't think I've ever damaged a pad, but I have nicked the PCB before, which you want to try to avoid, obviously, if you can help it. So I'm going to kind of flip this the other way because there's a little bit more space at the other end of the PCB. Same with the envelope. So, actually I guess the envelope is not upside down. Yeah, no, it's got resistors at the very end of the board, so I'll leave it that way. Alright, and let me clean the tip again here. And then I just gonna reflow, clean it up a little. That one looks so good. There we go. Just making sure. Sometimes when you go top down, the pads on the underside don't get fully coated with solder. And I just like to ensure that they're solid. That looks good. Do the same thing on the envelope. Okay. Alright, that looks good as well. So, that's the first step down. So with each of these, we have a handful of capacitors, more so on the LFO. There's 5 versus 3, I believe. Is it 3? Oh, no, 2. Okay. 5 versus... Oh, no, 4, but 2 of them are electrolytic. 2 of them are ceramic. Over here, it's 5 ceramic, so... we could either do those next, or we could do the sockets and things next. I think I'll go with capacitors. We'll do the ceramic first. Again, these do not have a polarity to be concerned about, so I'll just place them. Oh, and let me also just mark off my sheets as I go here. So we've done all our resistors and diodes at this point. Okay. All right, that's that. And let's do the ceramics on the LFO. Now again, with these, rather than mess with bending the leads out and stuff, since the pads are very accessible on the top of the board, obviously you have to be using a fine enough tip on your iron for this to work. I use a pretty fine tip when I'm working, but I just like to tack down at least one of the pads from the top side, that way I don't have to worry so much about like messing with the leads and bending stuff. I just kind of tack it down and then flip it over and do the soldering on the reverse. Plus, I mean, I'm just adding to the conductivity of the thing, so no harm there. Crooked for a second, but we float it, fixed itself. And really, I might even do both in a case like this because they're so easily accessible. Again, I don't expect people, I wouldn't recommend you copy my methods. They're a bit OCD and kind of unnecessary, but this is how I do things. That one I already did both. All right, and then handle these here. All right, and so let's trim those leads and clean up the backside. I think in this case, it actually looks like none of them really float all the way. I mean, they float a little bit onto the other, the pads on the other side, but not too much. So I'm just gonna do one at a time so I don't lose track of any. that. And these ones I can group. Okay, let's do these. Okay, so there's that one. Now we just got the 2 to do on this one. Hang on a second. Always love the spam. Thanks for the spam. Yeah. Get that out of there. Bye-bye. Now, last time... Okay, there we go. Can't even do a live stream to no one without spam. Go figure. It's just a world of bots out there. The dead internet is real. Alright, so let's see. Let's get this. Alright, so that's that, and now we have our 2 electrolytic capacitors. Positive lead goes on the bottom. It's going to be our long side, has a square pad. Now, just to cover again how I tend to do these. Again, I don't know that you should follow my lead on this. Depending on how long you hold the soldering iron in place, the capacitor can get hot. I move very quickly, so I don't have any problem, but I'm holding the capacitor in place with my finger. I have the solder in the helping hands here, and then I just use it kind of aim for the pad with the soldering iron heating the pad, and there you go. And then I'll just add the other one in traditional fashion, but okay. And we'll do it again with this one. And the point here is just to get it secured to the PCB, make sure it's flush. And like not really have to worry about bending leads and stuff. I think for me, that approach sometimes led to, even with the bent leads, sometimes they'd like slip around or be, again, I'm unnecessarily OCD about the look of everything once it's done. And I like everything to be like nice and clean and flush to the board, so I go a little overboard to ensure that, I guess, but okay, so then we'll clip these leads. And I'm just gonna, real quick, like just kind of clean those up, reflow them. And I'm going, I'm alternating leads just to give the initial ones a chance to cool and kind of solidify real quick before I touch the other half so that nothing slips. Okay, so there we have that. Looking pretty clean. I think this time, I haven't been doing this on prior streams, and just to show you the process, I probably will throw these in the ultrasonic cleaner once I get the other two sockets on here. I'm not going to do that once the pots are in place, because I do always worry about mechanical components being damaged in the ultrasonic cleaner, but we can at least do all of this stuff. Should be totally fine in there. So next we'll do the more slimline sockets. Again, this whole approach, you got to be very careful in this case, because the pins that you're soldering on the bottom of the board are exposed here as the sockets. So, you know, you want to be very careful to make sure that what you're heating down here isn't what you're touching up here, or you'll get a nice little burn. But this is just how I secure these. I'm kind of backwards from my usual grip, so we'll see. Hopefully this isn't awkward. Yeah, that's good. Just double check that, make sure I don't need to reflow. Nope, looks nice and flush. And we'll do it again on the other end. I like to do opposing corners just to lock it down. Have it nice and secure. So there you have that. And just stick it back in the clamp here. Do this one, and then we'll solder both of those fully. I gotta clean the tip of this iron again. It's getting a little crusty. Okay, that looks good. Make sure that's flush. Okay, same, still looks good, still flush. So we're gonna put this back in the clamp. I'm gonna clean the tip of the iron real quick. Nice and clean. And grab this solder out of the clamp, and now we'll go and finish these pins here. Okay, there's that one. And there's that one. Okay. Let's get the socket, the power sockets on there. So notch in the socket, notch on the silk screen. We're gonna orient like that. Same procedure as the previous socket in terms of how I lock it down and secure it. With these ones, there's usually a little bit of wiggle room, and I like to try to square it up as much as possible with the silk screen. I just think it looks nice. No one's ever going to be looking at these, but, you know, I like it. And with a project like this, that's kind of what matters, so, you know. Okay. So that's nice and flush. Squared to the silk screen. Looks good to me. So I'll put it in the clamp and then we'll finish that up in a second once we do the other one. So here we'll get this. Again, notch in the socket, notch on the silk screen. Make sure those are aligned. Lock down pin 1 first. It's the square pad in case you're not familiar with how that works. And then we'll do this other opposite corner pin here. Okay, looks flush, looks square. I'm happy. Sounds like lyrics. All right. Whoops. Let's do the rest of these. What's happening? Oh. No. I'm gonna have to check that one under the microscope. I was like almost bridging it, but I don't think it did in the end. Just to be sure, though, I'll take a look. Slow that a little bit. Okay. 2 more. Looks good. Okay. Okay. So that's that. Let me just double check these under the microscope real quick. Yep, all good there. Just generally looking over the whole thing. That looks good. There's one pad that isn't like fully flowed, but that's fine. It doesn't look like anything problematic. Okay, that one's also looking good. All right, so at this stage, you know, all the components on the board are pretty durable. We haven't placed any of the mechanical stuff yet. The LEDs still have to be added, but we are almost done. So what I'm gonna do real quick is I'm just gonna throw these in the ultrasonic cleaner. Now, if my microphone is live here, which it will be because my mute switch is in the other room, this is going to sound kind of like one of Ben Jordan's ultrasonic jammers, microphone jammers, because it will, I mean, it makes quite a racket that in the room you wouldn't hear, but on the mic it gets flooded. So so now another one of my, like, you know, don't try this at home kind of things. I do have isopropyl alcohol in here, and you want to make sure if you're going to do that, don't ever run the heating unit. A lot of these have a heating unit. You don't want to heat the isopropyl alcohol. It is kind of a fire hazard to keep it this way. I'm very careful around it, and also just in general, in terms of how long I run it and all of that sort of stuff. So I'm just going to do a quick 3-minute clean here, and just the ultrasonic, no heat. 1 second here. Yeah. And again, this is going to sound like terrible noise probably on the mic when I start this. Doesn't sound like this in the room, but the mic's going to pick up the ultrasonic frequency, so. Oh, it's not that bad actually. You don't really hear that. Interesting. Maybe it wasn't this mic. I think I had a microphone. It might have been one of the wireless ones that just went a little crazy when I ran that. It sounded like it was being jammed, basically. Okay, so that needs a minute or two there. Just gonna check something. All right, while we're at it, while that's running, I'm just going to clean up these clippings here. Cool. 1 second. Gonna set down the headphones so I can get to the trash. All right, I'm gonna stop this. It really doesn't need to run for the full 3 minutes. Power that back off. Should be good at that point. There wasn't a ton of flux on those boards, so that's why I'm not too worried about it. I do want... I used to have paper towels out here, but I don't think I do anymore. I'm gonna have to fix that, but these should dry relatively quickly. I actually have a food dehydrator that I'll throw them in if I want to dry them especially fast. We'll see how fast they go, but I might have to go grab a paper towel as well just to kind of hurry them along a little bit. But you'll then see the backside of these are much cleaner once they dry, once it becomes more obvious. In fact, I might actually... This is the other reason why I don't usually do this part like on stream at all, because there is a bit of a wait period to dry these off. I might throw them in the dehydrator just to warm them up and try to get that alcohol evaporated. But yeah, they look good. Looks like it pulled all the flux off, which is what I wanted. So 1 second, let me just plug in the dehydrator and we'll just try to hurry this drying along a bit here. The main thing this is for is for baking reels of tape that are starting to fail. Actually, the guy I bought my Atari from provided it along with it, which was fun. So let's see. Yeah, so we can just kind of, I'll try to elevate them a little bit here with this extra piece. I'm just going to set them in here for a few minutes in the hopes of evaporating some of that alcohol to the point where we can at least work with them. So what else? Oh, you know what? And the other thing is, I think I may have dropped one of the nuts for the pots on a previous stream, so while this is going here, give me 1 second. I'm just going to put up the sort of be right back messaging, because I'm going to be crawling around on the floor real quick to see if I can find this other nut, because we need one more, and I'm pretty sure that's what happened. I can't remember for sure, but it's either that or the kit's missing one, but the kit's been real solid with all the other parts, so I kind of doubt that that would be the case. And it's very rare for Thonk to miss parts. I don't know how they do it, but their kits are always extremely accurate. So 1 second, I will be right back. Okay, well, if I did drop one, it's not anywhere that I can actually see, so I'm not going to spend too long on it. Let's see, how are these doing? That was fast. Alright, cool. They look pretty dry. That. So there's a little bit of residue on here. Sometimes that happens. They feel a little like, I don't want to call it sticky. It's not sticky, but they feel like a little oily or gummed up. But that part can be cleaned easily. Just clean it with a cloth or something. But as you can see, a lot cleaner than before. While there is a little bit of flux residue just kind of distributed over them now, I think I probably need to swap the base in that ultrasonic cleaner. Get that refreshed, because it seems like there's probably a fair bit of flux floating around in there now at this point. But that aside, and it breaks it down well enough that at that point it's much easier to clean off. So there we go. Those look pretty clean, pretty good. Not perfect, but not terrible. And so from here, we basically just need to attach the faceplates and add the remaining hardware. So that's the 2 pots, the LED, and the 2 jacks for each. So let me get my chair back over here. And by the way, the music we are listening to has been the same the whole time. This is a band that goes by El Flaco Collective. That's on Epidemic Sound, so I don't know if... I think Epidemic requires kind of exclusive agreements with the artists, so I don't know if they're available on other streaming services and stuff. I'll have to check into that a little bit more, but all of the music we've been listening to has been this particular artist, so I don't really know anything about him, but I like the sort of Afro-funkish thing that they're doing. So let's place the pots. Again, we're down 1 nut for these, so I'll have to sort that out. Okay. And I always wait man, I lost my train of thought mid-sentence. Hate when that happens. I always... What was I going to say? Oh yeah, I always wait to place the ICs until I'm totally done soldering everything, just in case. Alright, so in this case, the positive leg is up top. And then we have our jacks. So we will add our faceplate here. Just taking a look. And just kind of lock this stuff down. Again, we'll only be able to lock down 1 of the pots because I'm missing this nut for some reason. I can maybe run to the other space and check real quick. See if I have any spares. Okay, and then the other jack nut. Oops. Sleepy. And then what I like to do with these LEDs when they're set up like this, I think Ben said in the kit manual, he says that he likes to just like have them so they're poking through the faceplate, but my preference is different. I like them flush. So what I do, let me see, do I have packing tape in this room with me here? Thought I did. I know there's some in the studio here. I might have to run to grab that. 1 second. Yes, I think it must be in another room. I'll be right back. Okay. So what I like to do with these LEDs for them to be flush on the panel is I'll just take a little piece of clear tape, packing tape, magic tape, whatever, and I just place it on the panel like so, and then I'll get the LED aligned and I just stick it through and kind of stick it to the tape and then solder in place like that, and then that'll get us a nice flush LED. Alright, so now let's do the same thing for our LFO. Straighten the legs on this pot real quick. There's that. And then these jacks share a ground. So you gotta work that in there. And then our LED. One leg. Place that. We'll lock the jacks down. Finger tight is fine for this step, as always. Okay, and we'll lock the pots down. I always think I'm doing this stuff on camera, but unless I like really extend it out further, I tend to be like halfway off camera, so sorry about that. Okay, there's that. I need to get kind of like an extension monitor that I can have in front of me here just to make sure I can see what I'm doing without turning around. All right. So then, again with the packing tape, just make sure the LED's flush. And again, LEDs do have a polarity orientation, so we did have to make sure we observed that when we placed it. Just one thing real quick. Okay. Yeah, I was just verifying because the capacitors, the positive lead has a square pad, and then for some reason that's then reversed on the LEDs. I don't know if that's a convention I'm not familiar with or what, but I just wanted to make sure that I had seen things correctly and that I didn't accidentally swap the capacitors around in terms of polarity. Anyway, all right, so then we can start soldering. 1 second, I got a text here. All right. So, let's see. Oh, you know what? Let's fix this one. I guess it looks like somehow my camera moved a little bit to the point where actually maybe That's interesting. All right, so the stuff that's closer to the camera needs to be further in to be in shot. Interesting. Yeah, there's something I haven't quite understood about the way this lens works. It seems to have some distortion to it that is interesting. Anyway, because it's kind of a diagonal line from you know, like, so I marked out the place on the desk surface that is supposed to be in frame, but apparently that's only when I'm working down at the desk level, and that box gets significantly smaller the closer to the camera I get, which I hadn't quite thought through, I guess, but... Oh yeah, and also, let me put Twitch chat back up. There we go. All right, so that's those jacks. We'll do these next. Alright, so we've got those. Let's now do the pots. Hopefully I'm not blocking the camera here. Okay. Hello, PDB. How are you? How was your trip? Oh, can you hear me? I can't tell. Okay, cool. You got 2 magazines from the 60s. Oh, that sounds cool. What kind of magazines? Life and German life. That's very interesting. How different is the content in them, given the variation in demographic, I would assume, between those two? Are you going to translate the German one? The Germans were drinking more alcohol and the Americans were buying more appliances. Yeah, okay. That sounds about right. Especially for that time period, anyway. did you get it like for the reading content, or did you get it as like collage material kind of stuff? Nice. Oh, okay. So just more like viewing material. That's cool. Yeah, we have to preserve our history here. In this ephemeral digital age, we have to make sure what artifacts remain, stick around, right? I'm almost done with these builds here. Putting on the last little touches. Got to place the IC, and we're set. We can test. Oh, I guess I answered your question before you asked it. How's your DIY going today? Well, we are almost done with the last 2 builds in this modular kit. And so once I place these ICs here, I do also have to tap the holes in the enclosure so that we can mount them in the case. And then we can test everything, and, you know, barring any surprises, should be good to go basically. So I'd say it's going pretty well. I wanted to have the builds wrapped up by noon. As you can see, I'm pretty close to being on time for that, so. Neat. Yes, I think it's neat as well. Alright, let's see. So I'm just going to reflow these LED pins here just because since I clipped them, everything else looks good. Alright, so then these last 2 ICs, let's place them. So these are the TL074CN, so they're inverting op amp. We'll straighten those legs. And there we go. Oh, well, one last thing. Although since I'm missing the nut for this one, I'm not going to place that knob just yet. Let's take the tape off that held the LED flush. Put that in my trash pile over there. And we'll place one knob on this one. The other one can have both, since the other one has both the nuts in place. This one needs let's see. Nope, that's not quite right. I like to make sure that these are as even as possible on each end of its travel, so that looks good there. Okay. Again, these are little OCD touches that other folks don't necessarily need to bother with. It's just how I roll. But Let's make sure these more or less match. That looks good. And same with this one. All right. Oh, looks like once I press those down, which one is... All right. That might not even be visible to some folks, but it looks to me like these are off by 1 notch on the head there. Okay, there we go. Now I think they're aligned. Yeah, they're a little bit different, but just ever so slightly. It looks good to me. Okay, so just gonna quickly see if I have an extra nut for this one here. I somehow misplaced one. You like my OCD touches? Well, thank you. I do too, or I wouldn't bother with it because it is extra effort, but it does help to make it look nice and tidy in the end. All right, let's see. Do I have any spare? This is like a random parts pile that I haven't really cleaned up yet. It's just kind of like the tray that absorbed all the spare parts from various builds that I've done recently. Well, I don't think I even want to admit what recently means in this case because it's not as recent as you would think, but sometimes it takes me a while to get around to the cleaning I need to do in here. That's all I can say about that. Let's see. No. Not here. Alright, well. Yeah, I won't waste time on stream trying to locate something for this, but I will need to find a compatible nut so that I can install the pot on this one. As it stands, it's just going to have to float for now. Wait, I think I might have missed the timing on that to understand what about 3 years means. About 3 years of extra time required? Oh, about 3 years to get around to the cleaning. Ooh, it's less than that. I don't know how I should feel about that assumption. No, but you're not far off. It's about 1.5 years, so you extended by about 100%, but yeah. Okay, well, so this one will have to wait to be finalized until I can get that piece in place, but it's about as finalized as it needs to be tested and such. Let's turn this stuff off for now. Alright, so get this tray out of the way here. Okay, you're heading out? Alright, sounds good. Do I want a sandwich? Yes, please, but I don't know when I'm going to have a chance to eat it. Might be a minute, but yes, I would gladly take one. Thank you. Love you. See you soon. Bye-bye. And it's probably obvious, but that's my partner, Patricia. So they were out on an errand. have returned with magazines from the 60s. Okay. And they, in this case, they being her and our daughter. So it's since that could have been a group or a singular pronoun at this point in time. So just to be clear. Okay, so let's get this in place here so we can kind of see what we're doing. All right, that's good enough there, I guess. All right, so I'm gonna mark as soon as I remember where I placed my Sharpie. Yeah, there it is. I'm just gonna mark the holes in the enclosure that need to be tapped. I've been having pretty hit and miss kind of luck with this, so hopefully I don't ruin these. But you know, it is what it is. If I do, I do. It's fine. Everybody will survive. Alright, and then I'm just marking the holes that need to be tapped. And so that would be here. And so then it would also be this one for the blank plate at the end. Alright. So let me fix this. There we go. That's more secure. That one looks good. All right. So I'm just gonna carefully and briefly tap these holes here. Hopefully this works out. Oh, had it the right way the first time. One at a time. We'll test and see how we did. All right, so I'll place. I guess I'll do the envelope first in order here. So we'll plug that in. Fold the power cable down out of the way as much as possible, and then let's install this. Where did I put those screws? There they are. Oh yeah, and I'm gonna have to go run to the other room to grab some more M3 screws. Let's see. Okay. Hooray. I didn't ruin it. I'm gonna back this one out just a hair so that I can slide it over a little. Let's get the other one in. All right. Yeah, those taps went okay. It's always a bit of a relief when that is the case. All right, so those taps are good. Let's do the LFO. And we'll just carefully tap these. I think that went far enough. It looks like it. Okay, back it off again. Alright. Let me go grab a couple other screws. Be right back. Okay. Alright, so nice thing is in my studio case, I use knurlies. So anytime anything comes with a bunch of screws, I just have a box that I put everything in, and that's where it all lives. And then in times like this, I have spares. It's very helpful. Alright, so it did seem, I was a little surprised. It seems like the kit did not account for, I guess maybe the blanks? Because if it weren't for this blank over here, I would have had enough screws for all the modules, just not the blanks. But the kit's set up in such a way that you kind of, like, it makes sense to install the blanks, so that part's interesting. But anyway, I can understand why they omitted them. It's not a big deal. Okay, so this for, yep, that one looks good. Oh, gotta back it off a little too far away there. Oh, nope, that one's wrecked. Alright, well, can't win them all. So let's do this. Yeah, I was a little worried because when I did that one, I think both of them, I was a little bit too close to the head of the microscope there, and I didn't really account for it until I was already tapping the hole, and then realized that I wasn't really leaving myself enough space to not cause a problem. But you know what? It's fine. We'll just go with another piece of gaff tape. And at some point, I will repair these threads, and then it can look nice, as it should. But for now, it's fine. Alright, so let me give myself a little bit of extra space for these last two to tap these. Good. Okay. A little too wiggly. That one might have some problems. We'll see. Might have wiggled around too much when I was finishing that. Alright, so we'll put this other blank on here. And then we're ready to test. Place that carefully. Yeah, looks like it's not bad, but that little bit of wiggle meant that it's not tight enough to lock down. Alas. It's not going to fall out though either, so that's alright. That one, on the other hand, is good. So, at least I'm starting to be able to spot the problems when I tap a hole. At first I didn't really notice when I would mess something up. At least now I can tell that it's botched before I even try it. Alright, so let me just clean up a couple small things here and then we'll test this. I'm dropping stuff on the floor. Okay. Let me take off the headset real quick so I can get across the room to the trash can. 1 second. Alright, so I think if I go get a patch cable real quick, we can at least visually inspect and test both of these without even having to plug them into the modular, the main modular, but I'll do that in a second, but I just want to verify them real quick out here while we're set up because we've got power and stuff close by. So let me grab a patch cable, because what I'm going to do is I'm going to use the LFO to trigger the envelope. That should work, assuming the voltage ranges are appropriate, which I think they will be. And so we should be able to see by the LEDs lighting or not, whether or not the circuit is working as expected. So, and then we can test all the outputs and all of that stuff in the other room with the modular, and just kind of make sure everything's good. So 1 second, I'll be right back. Alrighty. So, let me plug the power in here. Make sure nothing just like immediately fails. Which I don't think it will, but you never know. Okay. Alright, power there is good. Alright, so we have what appears to be working LFO. Can you see that on screen? Can you see yeah, you can see the LED blinking essentially. So let me get everything more in view here. We'll turn that light off so we're not fighting it. All right. So now I'm going to take the pulse out, which is kind of like a gate anyway, and we'll Take the gate in. All right, so there we go. So there's, you can see it's sort of fading in the LED. So we've got a slower attack. If we push it this high, looks like maybe the attack doesn't even quite finish. There we go. By the time, now I'm not seeing, I'll have to look at this on a scope because I'm not seeing a whole lot of variation in the attack in the later ranges, which is interesting. So I'm curious about that. I'll have to take a look. And then, yeah, I don't... Let's see if we can... Yeah. Okay. All right, cool. Well, so in principle, everything appears to be working. So now we can take it over to the other room and actually test the audio and just kind of hear this. I mean, now we have the whole system. Again, I won't at the moment be using anything from the microcontroller because I have to do a little bit of troubleshooting on this input, and without that, it's a bit of a pain to kind of connect it and stuff, since I have to go direct to the Raspberry Pi on there. But skipping that one, we've verified everything else's function, and now we have an LFO and an envelope on board, so we can do some slightly more interesting stuff. So yeah, let's take a look at this and see what we can do. I'm gonna get a drink of water, and we'll switch over to the cameras in the other room, get set up, and see what we're dealing with. I wish I hadn't lost that one nut. Bit of a shame, but that's alright. I mean, I guess... Wait, did I put the washer on there and then somehow lose that? Why would I do such a thing? Did I do that? Alright, I don't know. But I thought there was a washer on this module, because I thought I was going to go off and look for the nut, and then I don't know what I would have done to have dropped that, but maybe I did. And this is how I lose things, folks. This is... I have this habit of just like, I'm really good at misplacing things in a very small radius. Like, I don't have to go far, I don't have to do much, and I will find a way to misplace stuff and just like kind of lose track of it. I'm not sure what that's about, but it's kind of a special skill that I've developed over the last 10 years or so. Anyway, all right, so I'm gonna pause real quick, get a drink of water, and then we will relocate to the other room, and we can play with this a bit, test it. I'll probably just go from the Keylab gate and CV output straight into this thing so that I can just verify it that way, because now we kind of have everything we need in that regard. I will have to mult the pitch output, but that's about it. Yeah. All right. So 1 second. We'll switch over to this. Oh, but let me... All right, hang on. All right.